Imagine peering through solid rock, unveiling hidden chambers and ancient artifacts, all without ever lifting a shovel. This isn't science fiction. This is the reality of muon imaging, a revolutionary technique that uses cosmic particles to see through the world around us. We are constantly bombarded by cosmic rays from the vast expanse of space. These rays interact with our atmosphere, creating a shower of secondary particles, including muons. These muons, like tiny cosmic messengers, hold the key to unlocking secrets hidden deep within structures, both natural and man-made. Muons are subatomic particles, similar to electrons but much heavier. They are incredibly small, yet they possess remarkable penetrating power. This is because they are minimally affected by the electromagnetic forces that govern the interactions of most other particles. Born from the collisions of cosmic rays with atmospheric atoms, muons rain down upon Earth in a constant and predictable flux. Every minute, about 10,000 muons pass through an area the size of our hand. These particles, invisible to the naked eye, hold the key to a new kind of vision, muon vision. Muon imaging works on a simple principle. Denser materials absorb or scatter more muons than less dense materials. This fascinating technique leverages the natural properties of muons, which are subatomic particles similar to electrons but much heavier. These particles are constantly being produced when cosmic rays collide with atoms in the Earth's atmosphere. As muons pass through an object, some are absorbed, while others pass through with slight deviations in their trajectory. This deviation is key to understanding the internal composition of the object. The more dense the material, the more muons are absorbed or scattered, causing fewer muons to reach the detectors on the other side. By placing muon detectors around or on either side of an object, we can map the distribution of these particles and create a three-dimensional image of its internal structure. This method has been particularly useful in fields like archaeology, geology, and even in monitoring volcanic activity. The ability to see inside large and dense objects without causing any damage is revolutionary. Think of it like an X-ray, but instead of using harmful radiation, we use naturally occurring cosmic particles. This makes muon imaging a safer and more environmentally friendly option for probing the unknown. Unlike traditional X-rays, which can be harmful with prolonged exposure, muons are harmless and abundant. The more muons that pass through a region, the less dense that region is. This allows scientists to identify voids or less dense areas within a structure, which can be crucial for various applications such as finding hidden chambers in ancient pyramids or assessing the integrity of large infrastructure projects. Conversely, areas where fewer muons reach the detectors indicate the presence of denser materials. This information can be used to map out the internal features of mountains, detect mineral deposits, or even monitor the stability of volcanoes. The potential applications of muon imaging are vast and continue to grow as technology advances. There are two main types of muon imaging: muon transmission radiography and muon scattering tomography. And muon transmission radiography provides a two-dimensional projection of the object, similar to a traditional X-ray image. It's particularly useful for quickly assessing the internal structure of large objects. On the other hand, muon scattering tomography creates a detailed three-dimensional image by tracking the scattering of muons as they pass through the object. This technique offers higher resolution and can be used to identify specific materials within the object based on their scattering properties. Building a muon detector. Muon detectors are sophisticated instruments designed to capture these elusive particles. They typically consist of layers of scintillating material which emit light when a muon passes through them. This light is then amplified and recorded by sensitive photodetectors, allowing scientists to track the path of individual muons. The size and configuration of muon detectors vary depending on the application. For imaging large structures, detectors may be the size of a small car. In other cases, portable detectors can be used for smaller objects or to access tight spaces. Muon imaging in the real world. The applications of muon imaging are as diverse as the objects it can see through. This advanced technology leverages the natural properties of subatomic particles that can penetrate deep into materials to create detailed images of the internal structures of objects. In archaeology, Muon imaging has been used to explore the pyramids of Giza, revealing hidden chambers and providing valuable insights into their construction. This non-invasive technique allows researchers to peer inside these ancient structures without causing any damage, preserving their historical integrity. Geologists use Muon imaging to map underground geological formations, aiding in the search for natural resources and the prediction of earthquakes. By understanding the subsurface structures, scientists can better predict where valuable minerals might be found and identify fault lines that could lead to seismic activity. Civil engineers utilize Muon imaging to inspect bridges and tunnels for structural defects, ensuring public safety. This technology can detect weaknesses and potential failures in infrastructure, allowing for timely maintenance and repairs, which is crucial for preventing catastrophic failures. And in the realm of nuclear security, Muon imaging can be used to non-intrusively inspect cargo for illicit radioactive materials. This application is vital for preventing the smuggling of dangerous substances, ensuring that ports and borders remain secure. The versatility and non-invasive nature of Muon imaging make it an invaluable tool across various fields, from archaeology to public safety. Section 7. Cosmic vision versus X-ray vision, a tale of two imaging techniques. While both Muon imaging and traditional X-ray imaging allow us to see inside objects, Muon imaging offers several advantages. First and foremost, muons are naturally occurring and non-hazardous, unlike the ionizing radiation used in X-rays. This makes Muon imaging a safer alternative, especially for sensitive applications. Secondly, muons possess far greater penetrating power than X-rays, allowing us to see through much denser and thicker materials. This is particularly advantageous for imaging large structures or objects buried deep underground. Section 8. The challenges of cosmic vision. Limitations of Muon imaging. Despite its many advantages, Muon imaging is not without its limitations. One significant challenge is the relatively long acquisition time required to collect enough Muon data to produce a high-resolution image. Depending on the size and density of the object, imaging times can range from hours to days or even weeks. Another limitation is the resolution of Muon imaging, which is generally lower than that of X-ray imaging. Additionally, building and operating Muon detectors can be expensive, limiting the widespread adoption of this technology. Muon imaging's transformative potential. Despite these challenges, Muon imaging holds immense promise for the future. As technology advances and detection systems become more efficient, we can expect to see faster imaging times, higher resolutions, and more affordable detectors. These improvements will make Muon imaging more accessible and practical for a wide range of applications, from scientific research to industrial inspections. With its unique ability to see through solid objects without causing harm, Muon imaging has the potential to revolutionize fields as diverse as archaeology, geology, engineering, and security. Imagine archaeologists uncovering ancient ruins without disturbing the ground, or engineers assessing the integrity of bridges and buildings without invasive procedures. Security personnel could scan large areas for hidden threats, ensuring safety without compromising privacy. As we continue to unlock the secrets of Muon vision, we open a window into a hidden world, providing insights that were previously beyond our reach. This technology not only enhances our understanding of the physical world, but also inspires new ways of thinking about the unseen, revealing the unseen wonders that lie beneath the surface. From the depths of underground cave systems to the hidden archaeological ruins and natural wonders, Muon imaging is set to transform our perception of the world around us. Please like, subscribe, and thank you for watching.